Terminal velocity, a dynamic system, by Hector and Matias. A falling object reaches stable equilibrium when its acceleration is zero and its velocity is constant. This is called terminal velocity and is achieved when the force of drag acting upwards is equal to the weight force of the object acting downwards. Any increase in velocity will cause the object to slow back down to terminal velocity, and any decrease will cause it to increase back up to terminal velocity. The total force acting on the object is weight minus drag. Weight depends on mass and g, while drag depends on the coefficient of drag, air density, velocity, and area. All of these will remain constant except for velocity. We can find the terminal velocity by solving for velocity when acceleration equals zero. Terminal velocity in this case will equal the square root of 2 times mg divided by coefficient of drag times rho times area.
Here is a video of an object being dropped. Look closely and try to see when the object reaches terminal velocity.
Yeah.
Now let's try to explain what is occurring. Here you can see the object at time t equals 0. As you can see, the weight is not opposed by any drag force, so the acceleration is equal to g and the velocity equals 0. Here we have the object at some time t1. We can see the drag force is becoming larger, which is directly due to the increased velocity. The drag force will begin to oppose the weight, which will in turn decrease the net force and the acceleration. In this final snapshot, at some time t2, when terminal velocity has been reached, the drag force and weight are now equal, and therefore the object's acceleration is 0, and its velocity is at a constant terminal velocity. In summary, the system is a natural continuous feedback dynamic system. The input of the system is velocity at time t, while the output of the system is both acceleration at time t and velocity at time t plus dt. Velocity is the element being directly measured in order to compute acceleration and the new velocity. The system has a negative velocity feedback. The coordinate system, like stated before, is a simple xyz coordinate system with the origin under the dropped object.
This is a Simulink-style block diagram of our dynamic system. Acceleration is integrated into velocity, then squared, then multiplied by negative cd rho a over 2m, then added to g to create the acceleration equation again. Acceleration and velocity can then be viewed as outputs. This is the end of our video. Thank you for watching.